All right, binomial theorem. First off, what do we mean when we call something? What do we mean when we call something a binomial? What is a binomial? Two terms. A binomial is a polynomial with two terms. So, for example, it's something like 2x minus 3y squared. Something like that is a binomial. So what we're interested in today is we want to find a way to calculate something like x plus y to the n power. So kind of like we talked about when we were doing powers of complex numbers, multiplying out those parentheses can get really long, difficult, tedious. It's a kind of a big problem. So we want to see if we can find an easier way to do it. So I want to look at a few of these. So I'm going to say x plus y to the 0. We're going to do a few powers. X plus y to the first. And I'm going to start writing these out. Well, what's x plus y to the 0 power? 1. X plus y to the first is just x plus y. X plus y squared, we get x squared plus 2xy plus y squared. Once we hit n equals 3, we get some. It gets to be a little more difficult, but we get x cubed plus 3x squared y plus 3xy squared plus y cubed. N equals 4. X plus y to the 4th power. Now multiplying this out by hand would be pretty messy. So we get this. And I'm going to do one more. And then we'll talk about the patterns that we see here. All right, so there is n equals 0 through 5. So what do we see? What kinds of patterns do we see? Yeah? So our coefficients are the numbers in Pascal's triangle. So I'm going to say a pattern and symmetry in the coefficients. What else? Well, how many, for n equals 0, how many terms do we have? N equals 1, we have 2, 3, 4. So we always have n plus 1 terms. How about the exponents? Yeah? Right, the exponents always add up to n. So here we have 5, 4 and 1 is 5, 3 and 2 is 5, 2 and 3 is 5, 4 and 1 is 5, 5. So our exponents add to n. Yeah? Right, and they descend, x descends from n to 0, and y ascends from 0 to n. So we have this ascending, descending exponents. Zero to n. So what mathematicians do, part of what mathematicians do is when they see patterns like this, they say, well, how do we can represent this pattern somehow. So that's what the binomial theorem is a way to represent this pattern. So you don't have to multiply these out. You take advantage of the pattern and the symmetry there to write out a formula for multiplying these binomials. So that's what the binomial theorem is. So the binomial theorem tells us that x plus y to the n power equals, we're going to sum, and our sum is going to go from 0 to n, because we saw our exponents go from 0 to n, or n to 0. We have n plus 1 terms, so since we're starting at 0, we're going to get n plus 1 things there. I'm going to leave a space here because I'll write this in a second. We're going to say x to the r n minus r, y to the r. This is going to make sure that our exponents add up to n, because n minus r plus r is n. And they're going to go from, the y is going to go from 0 to n, and x is going to go from n to 0. And this number out here in front, we can't just write the numbers from Pascal's triangle. Well, it turns out there's another way to represent those numbers. And this is going to connect with what we do next time when we talk about counting. And the way that we're going to write that is NCR. NCR is called the binomial coefficient. And we can also, you'll also see it written like this. And the way we can calculate this, and this is the same as the numbers in Pascal's triangle, n factorial over r factorial times n minus r factorial. So when we were simplifying factorials in the first section of the unit, we simplified a lot of factorials like this. And the way the way that I usually say this is n choose r, because this is going to connect with how we count certain things. So that NCR, n choose r. It's also a binomial coefficient, also the numbers in Pascal's triangle. So what I want to do quickly is show how to calculate these in your calculator. So we simplify these by hand, so I want to show you how to use your calculator. So 10 choose 5 is 10 factorial over 5 factorial times 10 minus 5 factorial, which is 10 factorial over 5 factorial times 5 factorial. So we know how to simplify this by hand. We can simplify those by hand. Let's use our calculator. I'm going to do 10 And then I'm going to go to math and arrow over to probability. And number 3 is NCR. And we're choosing 5. And I hit enter. All right, so what I did 10, go to math, arrow over to probability, and then go to 3, NCR, 5, and you get 252. If we wanted to calculate, the other way that you'll see this written is like this. This is 8 factorial over 2 factorial times 8 minus 2 factorial. In your calculator, I'm going to do 8. Go to math, arrow over to probability. The third one there. And then we're choosing 2, and we get 28. So, if I remember correctly, on the quiz, on the test, you can use a calculator, but I will ask you to, on the test at least, but I will ask you on some of them to show how you simplify the factorial by hand. So you can check your work with your calculator, but I want to see that you know how to do this by hand as well. All right, so let's talk about how we're going to apply this to the binomial theorem. So the kind of question you'll be asked with the binomial theorem is to expand x plus 2 to the 4th. And this is not asking you to say that this is this. That's not what it's asking you, to expand it that way. So we have to do something different. This is asking us to multiply this out. We want to use a binomial theorem. So I say x plus 2 to the 4th equals the sum r equals 0 to 4. 4, choose r. X to the 4 minus r, y, not y, 2 to the r. And then what we're going to do is plug in r equals 0, 1, 2, 3, 4 to get our 5 terms. So let's do that. So this is going to be, for r equals 0, we get 4, choose 0. X to the, I'm going to write it out explicitly this time just so we see all the calculations. X to the 4 minus 0, 2 to the 0. Plus 4, choose 1. X to the 4 minus 1, 2 to the 1. Plus 4, choose 2. X to the 4 minus 2, 2 to the 2. Plus 4, choose 3. X to the 4 minus 3. Y to the 3. And finally plus, yes, sorry. 4, choose 4. X to the 4 minus 4. And 2 to the 4. So my coefficient on this term is going to be 4 choose 0 times 2. My coefficient on this term is going to be 4 choose 1 times 2 to the 1st. sorry, 2 to the 0 here. 4 choose 2 times 2 squared. 4 choose 3 times 2 cubed. And here it's going to be 4 choose 4 times 2 to the 4th. So when I do that, I get x to the 4th. 4 choose 0 is 1. Plus 8x to the 3rd. Plus 24x squared. Plus 32x plus 16. And that's the answer. What's that?
Can we do this on the calculator?
The calculator will not do this. The TI-89 will do this, I think. All right, let's look at another example. Any questions there? All right, this example has something that a couple of things that we have to be careful of. We want to expand this. I'm going to rewrite this. I wouldn't have to, but I just want to get my variable first. I'm going to write this as minus x squared plus 3 to the 4th. And that's going to equal the sum r equals 0 to 4. 4 choose r. Here's one place that we have to be careful. This is negative x squared, so we get minus x squared to the 4 minus r. And here we get 3 to the r. So a couple of things that we have to be careful of. Here we have a minus x squared. So our signs are going to alternate between positive and negative, depending on if 4 minus r is even or odd. And we also have an x squared there. So whatever our exponent is here, we have to multiply it by 2. Yeah.
So even though because of the square, it's not oh, it's just kidding. I got it. Never mind.
Okay. So let's write this out. So this is going to equal 4 choose 0. I'm not going to write out everything as explicitly this time. This is going to be minus x squared to the 4th. 3 to the 0. Plus 4 choose 1. Minus x squared to the 3rd. 3 to the 1st. So remember, the first numbers go down. The second exponents go up. Plus 4 choose 2. Minus x squared squared. 3 squared. Plus 4 choose 3. Minus x squared to the 1st. 3 to the 3rd. And then finally, plus 4 choose 4 times minus x squared to the 0. And we get a 3 to the 4th. So this time, my coefficients are going to be 4 choose 1 times whatever sign we get out of here times whatever we get out of this one. All right, so when I do this, I get x to the 8th minus 12x to the 6th, minus because this is an odd power, plus 54x to the 4th minus 108 x squared, that's an odd power there, plus 81. And because this is an x squared, I get only even powers on x. All right, questions there?
I actually have a question.
Yes.
So if it was like a odd exponent, it would only be odd.
Yeah, because 3 times 2 is 6, so you could get an even.
Oh, okay.
You get even exponents out of that. All right, the other benefit of the binomial theorem is it allows us to isolate a single term in the expansion. So let's say we did some kind of statistical analysis, and the statistical analysis said the 8th term is the one that most strongly influences the data. Well, we don't want to calculate all the terms to figure out the 8th term. The binomial theorem lets us figure out a single term. So let's look at a couple of examples using that idea. Let's find the coefficient of x to the 8th in the expansion of x squared plus 2 to the 12th. So we don't want to have to multiply out all 12 of these things. We don't want to have to find every term. We just want to figure out what's the coefficient, what's the number in front of the term with x to the 8th. So we know that x squared plus 2 to the 12th is the sum. R equals 0 to 12. 12, choose R. X squared to the n, 12, n is 12. 12 minus R, 2 to the R. So we're looking for the term where x squared to the 12 minus R equals x to the 8th. So what does, in that case, 12 minus R has to equal what? 4. Because when we raise a power to a power, we multiply the exponents. So 12 minus R has to equal 4. So R equals 8. And it's a coincidence that this and this are the same in this particular problem. So now all we have to do is plug in R equals 8 here to find our coefficient. So we get 12, choose 8. X to the 8th, we know this is, and then we get 2 to the 8th. So my coefficient is 12, choose 8 times 2 to the 8th. And that equals 1, 2, 6, 7, 2, 0, x to the 8th. And the coefficient that we're interested in is that number. And this is way easier than calculating out all those terms.
That answer would be without the x thing?
Right. It wanted the coefficient, so it just wants the number. Like we calculated the term just so we see the process. All right. Other questions? One more example. Now let's say instead of the exponent, particular exponent that we want, let's say we just want a particular term. Let's say we wanted to find the 5th term in the expansion of 2x minus 3y to the 10th power. And we don't want to have to do all that multiplication to find the 5th term. We know the binomial theorem now. That's going to help us out. we know that 2x minus 3y to the 10th by the binomial theorem, r equals 0 to 10. 10, choose r. 2x to the 10 minus r times negative 3y to the r. What value of r gives us the fifth term? Because we're starting at 0. 0 is the first term. 1 is the second term. So 4, right? Because we're starting at 0. So the fifth term is when r equals 4. This is like the mathematician who they were moving, and his wife, the mathematician's wife, calls and says, "Did all the boxes arrive?" And the mathematician says, "Yes, there are 9." And the wife says, "No. They said they delivered 10 boxes." And he says, "No, I'm sure there are 9. Can you double check? There are 10 boxes." And the mathematician says, "Okay, 0, 1, 2." Kind of same thing. Yeah. So fifth term when r equals 4. So all we want 10 choose 4, 2x to the 10 minus 4, 2x to the 6th, minus 3y to the 4th. And we just calculate that out. So our coefficient's going to be 10 choose 4 times 2 to the 6th times negative 3 to the 4th. And we get 1088, 640, x to the 6th, y to the 4th. And this is positive because we have an even exponent. That's a pretty big number, too. And imagine multiplying this thing out by hand. All your parentheses to the 10th power. That would be horrible. We have the binomial theorem, and it's the opposite of horrible. It's quite pleasant. All right. Questions? Homework. Yes. Before I write the homework, how Pascal's triangle relates to the binomial coefficients. Is that what you were going to ask? No? So another way we can visualize Pascal's triangle is like this. No, this is another way that you can visualize Pascal's triangle. So some of the problems in your homework say use Pascal's triangle to calculate da 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 da. What they're saying is you can write out a few rows of Pascal's triangle and get 3 choose 1, 3 choose 2, 3 choose 3, 3 choose 4 from the row of Pascal's triangle. You do not have to. Some people like to write out a few rows of Pascal's triangles just so they can pick out those binomial coefficients. What's that? Yes, sorry. Trying to go too fast. So what you can see here is that 1 choose 0, 2 choose 0, 3 choose 0, 4 choose 0. All of those are 1. 1 choose 1, 2 choose 2, 3 choose 3, 4 choose 4. All of those are 1. And then you get the same pattern as Pascal's triangle. All right, there you go.